Hey guys, Kayla and Riley here. We're going to go over your Chapter 8 test. And we're going to start with the problems from 8.1 to 8.5, which is simplifying with exponents. So we want to make sure that all the exponents are positive. So I'm going to make sure that for this one, anytime I see a negative exponent, I'm going to make sure to stick it on the bottom. So I have r cubed on the top, t to the fifth stays, and then this t to the negative 7 goes to the bottom, and that becomes positive. So technically, when you have a negative exponent, that really means division. So when I put it on the bottom, that really means that I'm dividing. I'm getting smaller by that amount. So the next step I'm going to do is I'm going to use my rule that when the bases are the same, I just add the exponents. If I were to write that out, I would have 1, 2, 3, 4, 5, and then I would have 7. You get the idea. So if you count it up, you would end up getting 12. So t to the power of 12. So that is our final answer. All right, so for the next one, I'm going to use the rule that this exponent is going to get distributed to each of those. So I have a cubed to the power of negative 4, and I have m to the power of negative 4. Okay, and then I'm going to use my rule that I'm going to multiply these together. So I have a to the negative 12 over m to the power of negative 4. And just like we said, sorry, I just got to get down. Just like we said, when I have negative exponents, I'm going to make them positive. So when a to the negative 12 goes to the bottom, now it's positive. And similarly, I can do m to the power of positive 4 and stick it on the top. So that's my final answer. Because the bases are different, I can't combine those at all. All right, so next problem. So again, I see a negative exponent. I'm going to stick it on the bottom. Technically, that means I'm dividing. So we got rid of that. M squared is going to stay on the top. And then this m to the power of negative 3, that can go to the top and become positive. So anytime you have negative exponents, if they jump from top to bottom, they change in terms of their negativity. All right, so now I can use the rule that these have the same base. So I really have 2 of these and 3 of these. So altogether, I have 5 of them. Okay, or the rule shortcut, same base. If I'm multiplying them together, I just add them. All right, so for this one, just looking through all of them, I can easily see that anything to the power of 0 is just 1. So we don't need to do anything with that. So I have c to the power of 3, v to the power of 9, and then that negative exponent goes on the bottom. I don't really need to write the 1 because it's not going to change anything. Okay, so now I'm going to use the rule that because I have the same base and I'm dividing, that I'm going to subtract. So c to the power of 3 minus c to the power of 1 is c to the power of 2, and bring along that v to the 9th. So the reason when we do division why I can do that is technically that's saying I have 3 c's on the top. I've got 1 on the bottom, so those cancel and I'm left with 2. All right, so this problem, again, I'm going to put all negative exponents on the bottom. I'm going to write out everything else we got. So I have that, I have d to the power of 3, and I have k to the power of 2. So similarly, I could say that I have 5 k's on the bottom and 2 on the top, so they're going to cancel. Or I can just use a shortcut that I have more k's on the bottom, and so I'm going to do 5 minus 2. I end up with 3. And then I have h squared d cubed. So that's really the shortcut. But again, if you wanted to write it out, I'll write it right here. I have k times k on the top. I have 1, 2, 3, 4, 5 on the bottom. So those cancel, and I'm left with 3 k's on the bottom. All right, so last problem in this section, I have 9y to the 4th, j squared, and on the bottom, I have y to the power of 9. So just like the previous one, I have more on the bottom. I'm going to subtract. So these all go away, and I'm left with 5 y's on the bottom, or y to the 5th. And on the top, I have 9j squared. And because none of the bases are the same, I can't do anything else. All right, so that's it for this section. And in the next video, we'll go over the next part of chapter